Dear learners, my present discussion is on viscosity. When a body moves through a liquid, it experiences a frictional force in a direction opposite to the direction of the motion of the body. It is shown in figure 1. A body is moving with a velocity v towards the right, and the frictional force is acting opposite to v. It is an opposing force as it opposes the motion of the body. It is also called viscous force. It is due to the friction between the surface of the body and the surface of the liquid layer. It also occurs between two adjacent layers of a liquid if there is a relative motion between the two layers. The property of a liquid by virtue of which the liquid provides a frictional force or viscous force on a body or on a layer of liquid is called viscosity. Here two liquid layers are shown in figure 2. Two layers are in contact with each other. One is moving with a velocity v and the other with a velocity v1 and the other with a velocity v2, v1 greater than v2. Then there will be a relative motion between the two layers. So the upper layer, black layer will be opposed by the red layer. The motion of the black layer will be opposed by the red layer. So the frictional force or the viscous force acts along a direction opposite to v1. The upper black layer will pull the lower red layer to move along with it. The velocity gradient. Let us consider a flow of water in a river. We imagine the river water to be composed of a large number of horizontal thin layers of water. We think of a red marked layer which is at a height x from the bottom, that is from the river bed. Its velocity is v. And its adjacent upper layer is at a distance x plus dx with a velocity v plus dv. The velocity of the upper layers are higher and that of lower layers is low. Its adjacent lower layer is at a height x minus dx with a velocity v minus dv. The velocity rises with the increase of x. The change in velocity of the layers per unit change in x is called the velocity gradient. That is, the velocity gradient dv by dx equal velocity gradient equal to dv by dx. The upper layers has larger velocities than the lower ones. The velocity of the lowest layer in contact with the river bed is 0. Newton's laws of viscosity. The viscous force F is proportional to the area of the contact surface of the liquid. That is, area of the liquid contact liquid surface layer A. F is proportional to A. It is also proportional to the velocity gradient, that is, F is proportional to dv by dx. Therefore, we may write F is equal to eta A dv by dx. Eta is a proportionality constant. It is called coefficient of viscosity of the liquid. From this, we can define the coefficient of viscosity. The viscous force created on an unit area for unit velocity gradient is called the coefficient of viscosity. Stokes' law. If a spherical body moves in a liquid, then the viscous force acting on it is proportional to the velocity v, the radius r of the spherical body, and also proportional to the coefficient of viscosity of the liquid. That is, F is proportional to eta RV. F is proportional to eta R and V. F is proportional to eta, F is proportional to R, and F is proportional to V. Then we may write F is proportional to eta RV. F equal to some constant eta RV. This constant is 6 pi. So we can write F equal to 6 pi eta RV. This is Stokes' law.